Hello, welcome back. Today we'll be entering 4.3, which is horizontal and vertical asymptote. Now, entering the topics, we have three types to note. That is the vertical asymptote and infinite limits, the reciprocal function and limits at infinity, and horizontal asymptotes and limits at infinity. As you can see from here, the graph fx has a vertical asymptote x equals to c if one of the following infinite limit is true. If x negative, c tends to negative, limit x tends to negative c, and then positive, it will be positive infinity. And as limit x tends to negative c, it can be also negative infinity. C tends to positive infinity. C is positive, and then it will be positive too. And then we have the reciprocal function and limits at infinity. And as you can see, the limit x tends to positive infinity. 1 over x would be 0, and same goes for the negative infinity. And of course, there's the horizontal asymptotes and limits at infinity. Let's say if limit x tends to positive infinity, fx equals to L, or limit x tends to negative infinity equals to L, line y will equals to L is, and it is a horizontal asymptote of the graph. Let's move on. Entering the horizontal asymptote for these functions. So when we find these functions, we will try to make sure that the equation has the least amount of x. So we always divide it by x, and then using the limit, we equate it with 0. Alright, let us move on. So to start off, 3x plus 2 divided by x over 6x, 4x minus 1 divided by x. So we will get something like this. From here on, it's just limiting it to both positive limit and negative limit. Equated with 0. Negative 4. And then you do it the same thing for the negative infinity. The outcome will be the same. So the next question. X3 function. Make it into the limit positive. Two over 5. And then for negative, order to find the vertical asymptote, we have to make sure we do perform both limit tends to positive and limit tends to negative. Horizontal asymptote here will be (3/-4), and here will be (2/5). Moving on to the next question. Determine the vertical asymptote for the function x over x squared plus x minus 2. Alright, so here we will have to determine the behavior of the graph and the vertical asymptotes of the function. To start off, to find the vertical asymptote of the function, it's basically simplifying the denominator. So since the denominator is like this, we will get a function of x plus 2, x minus 1. So our vertical asymptote will be x equals to -2 and x equals to 1. Now, we have a region, basically, since we have found both values of x. We need to determine the behavior of the graph. So, we can create a table. And then we can determine the behavior of the graph. Creating a table is basically to understand it better and visualize it more. So we'll be putting tends to positive infinity and negative infinity. Tends to positive, negative 2, negative plus, negative, and 2 positive. If you sub any of these numbers, these numbers, into the equation, into the function, you get something more than 0 for this one. Less than 0 for the first one, more than 0 for the second one, lesser than 0, and then finally more than 0. And if you look at the table above, which is this one, the infinite limits for the vertical asymptotes, for this one, we can determine what is the behavior of the limit. And so for the first one, it will be a negative infinity, second positive infinity, negative infinity, and then positive infinity. So here we have determined the behavior of the graph. Moving on. Evaluate these equations using the limit as x tends to positive infinity. Same thing as the example 1, so we just do this. And then we got our answer, 3/2. And for this question, divided by x. Oh, as you can see, I have made a mistake in one of these questions, so please ignore it. I'm very sorry. Moving on, let us define what a vertical asymptote and what a horizontal asymptote is. So a horizontal asymptote is a horizontal line that a function approaches but never touches the line. Y equals to C. And vertical asymptote is a vertical line that function approaches but never touches 2. And there we have it. 4.3 and 4.3, vertical asymptote, horizontal asymptote, and reciprocal function. Alright, thank you very much. Today we will end the class here. Thank you.